Good morning, everyone. Thank you very much to the organizers for inviting me and for making it possible for me to be here. And thank you especially for allowing me to join you as something of an interloper in this circle. I join you as a political scientist who works on policy for science and technology. So I'll be speaking to you today about the policy and governance context of science on and from the moon, including for SETI. The international community is currently in the process, or in the early stages of developing rules that will ultimately govern activities on the moon and other celestial bodies. My main message to you today is that those efforts, such as they are at the moment, fail to protect scientific opportunity, unique and exceptional scientific opportunity on and from the moon. And that's a question that should concern many of you in this room, and perhaps even inspire you to take some action to steer the direction of some of these global governance efforts. So, as we know, we are on the cusp of what you might call a lunar renaissance. There will be, over the course of the next decade, a flurry of missions of many different types, civil, commercial, scientific, and otherwise, public and private, to the lunar surface and to the orbit of the moon. These missions will be numerous and diverse, and they're actually likely to individually each have larger footprints on the moon, specifically larger interference footprints on the moon than we've tended to assume in the past. At the same time, these many proliferating missions are likely to target what amounts to only a handful or a relatively small set of sites on the lunar surface, a relatively small number of very attractive but quite small destinations on the moon. Given that interference only takes two at any given site, we can already foresee the possibility, even the likelihood of interference between different missions at some of these high-value, high-interest lunar sites. That possibility of interference portends specific risks to scientific opportunity on the moon. The moon presents what we might call sites of extraordinary scientific importance, including some for astronomy, but arguably SESIs for a wide range of different scientific disciplines. Sites of extraordinary scientific opportunity are tiny patches, in the case of the moon, tiny patches of real estate that present unique, irreplaceable, often irrecoverable opportunities for high-impact scientific research that could change how we think about our world, how we think about the universe, how we think about ourselves, how we think about the origins of life on Earth. So they're highly valuable for astronomy and for other disciplines that feature these types of sites. In the case of astronomy, there are at least two examples that you've just heard described in the preceding presentations, The lunar far side is the most radio quiet place in the inner solar system, presenting unique opportunities for cosmology, including perhaps for SETI. In some studies, including by my co-author, Martin Elvis, there's a recognition that not only is the lunar far side itself a precious asset and the radio quiet environment there, and perhaps quite a large radio quiet environment there, is a unique asset to science, but what might be especially precious are very rare, large areas of smooth terrain that would make possible the emplacement of certain kinds of telescopes. These areas are very few in number, and when you eliminate a few of the constraints and competing uses, you are maybe left with really one such area on the far side that meets these criteria. Another example of SESI on the moon is the coldest cold traps, including perhaps cold traps with a very, very wide diameter. These cold traps could enable the emplacement of seismometers or interferometers that could allow for unique studies of gravitational waves. So there are possibly, of course, other SESIs, but these are just two examples that are especially important for astronomy and therefore perhaps also for SETI in some cases. So These SESIs are, in a sense, already under threat. We know that there's already radio interference on the far side of the moon from China's Queqiao satellite, which is currently a reversible problem. But we can envision additional forms of radio interference coming in the pipeline with additional relay satellites that are planned to launch. The cold traps are also very, very attractive to numerous types of different missions, including non-scientific missions. The cold traps are often co-located with or feature other attributes or other things that make them very attractive destinations for missions. Sometimes they harbor water ice, for example, that might be attractive to lunar mining missions someday relatively soon. But some of them are near the peaks of eternal light, which are very, very attractive topographical features for other, a wide range of different missions. So we can already envision the fact that other missions could approach or even visit these very same sites and in turn lead to the degradation of the scientific opportunity that exists at these unique locations. So we can already imagine today interference threats to these unique scientific assets on the moon kind of on the horizon. More broadly, there's a growing international recognition today that we need some kind of rules to govern lunar activities writ large, not just scientific missions, but the very wide range of diverse missions that we anticipate in the next decade or two. Broadly, because the long and the short of it is there is a very small number of very high value sites that are probably smaller in size than we've tended to assume, and a very large number, or at least a large enough number of missions, which each is likely to have a larger interference footprint than we have tended to assume, that will converge upon that small number of small sites. So that set of circumstances has already signaled to observers that interference between missions to the moon is foreseeable and that some form of coordination or management is going to be needed. So we already have an emerging understanding that we need rules for who can do what, where, and how on the lunar surface if we're going to avoid outcomes that leave everybody worse off, and certainly outcomes that create or inflict significant losses of opportunity on multiple players, including losses of scientific opportunity. There are currently 2 international efforts at developing what you might think of as lunar governance, or the beginnings of rules for activities on the lunar surface. They, of course, build on historical regimes and international treaties that govern outer space affairs, but they attempt to adapt and evolve those existing principles and understandings for this contemporary moment and for this next generation of lunar missions. The first of those 2 efforts lives in the United Nations system and is based in the UN Committee on the Peaceful Uses of Outer Space. That's the main international body charged with developing governance or rules for outer space activities. A second effort takes place within the context of the US Artemis program, and you can think of it as an international agreement that amounts to more or less the governance wing or the international institutions wing of the US Artemis program, and groups the US and its international partners. COPUOS has, about 2 years ago, established a working group on space resources with a work plan to study possible models for how to develop rules for the exploration and exploitation of space resources, so resources on celestial bodies, including, perhaps in the first instance, on the moon. The possible output of this working group will be recommendations for a regime or a set of rules that would govern these activities, including perhaps draft text for an eventual treaty that could be considered for adoption by the UN as a whole. So this effort is still very, very embryonic. We don't know ultimately what form it will take, but it represents one pathway toward developing a more comprehensive, global, multilateral set of rules for who can do what, when, and how on the moon. The second effort takes place within the US Artemis program. The Artemis Accords amount to an international agreement. It's a voluntary, non-binding agreement on principles and mechanisms that govern activities at celestial bodies, including space resource exploitation activities. The Artemis Accords have developed very swiftly. They have going from 0 to 26 signatories in just about 2 years. So they're really a very, very dynamic arena or setting for the development of rules for lunar activities, and you could say for international governance writ large. Now, we can debate the merits and demerits of these two particular efforts at developing rules for the moon. There are different characteristics, strengths, and weaknesses. But for our purposes, I think the long and the short of it is really to stress to you that neither of these efforts, not what's happening at Kopos, and not really what's happening in the context of the Artemis Accords, neither of these efforts really prioritizes protecting scientific opportunity. Neither effort is poised or really designed or intended to protect SESIs on the moon. The Artemis program and the Artemis process is still, at the end of the day, really focused on human exploration missions and facilitating those, as well as supporting the emergence of a commercial space industry, including perhaps commercial space resource exploitation. Kopos, for its part, has been concerned with similar questions and appears really preoccupied with how exactly to share the benefits of what could be space resource exploitation in the future. But both of these efforts essentially overlook, and you might even say neglect, protecting a global public interest in protecting scientific opportunity on the moon and managing interference in such a way as to ensure that the sites and conditions that we've identified as so uniquely, or that we're beginning to identify as so uniquely valuable to science, remain safeguarded for research and discovery. So, what does that amount to? I think for the people in this room, that presents something of an agenda for action, or a case for at least becoming interested in the governance dimensions of lunar activities. I'd argue that that translates into really a twofold agenda for the SETI community and adjacent sympathetic scientific communities. The first is a kind of internal agenda, or an agenda that's internal to the scientific community, the community of professional researchers who are actively engaged in or specializing in science on and from the moon. For that, within that internal agenda, there are at least 4 big objectives. The first is to establish some form of global process to identify, characterize, and protect SESIs. A first step toward protecting the SESIs is to actually develop really to identify what the most important ones are. We're still at the very early days of even doing that. So a systematic effort to identify SESIs, not only the ones that apply necessarily to SETI and astronomy, but perhaps to think about them more generally in a way that cuts across disciplines that might conduct science on or from the moon. It's also essential to actually think in the most concrete possible terms about what could be lost if we fail to protect SESIs. So can we think about quantifying in some way, or at least characterizing the most forthright, blunt, candid terms, what would be the losses to science and to the global public interest in science if we failed to take any action to safeguard these unique assets. I think the lesson that the astronomy community has drawn from the emergence of mega constellations that have threatened the dark and quiet sky is really an instructive one. I think before we saw the actual threat to the dark and quiet sky, not too many people really thought of the dark and quiet sky as scientific equity in need of defense, or as a scientific asset that needed to be safeguarded for science to take place, for scientific research to continue. So part of what's important now is to even realize what could be lost, and then to convey the value of what could be lost in the most concrete terms possible. In these conversations, there will be trade-offs between measures that protect science and measures that are supportive of, say, commercial space missions. So advocates of commercial space missions won't hesitate to quantify the potential losses that they may experience in the trillions or maybe even the quadrillions of dollars sometimes, right, as the fanciful projections often go. So it's crucial for the scientific community to be able to meet those kinds of rhetorical claims with their own characterization of the value of these sites. It's important to say forthrightly and candidly that some of the scientific opportunity that could be lost if these sites aren't protected are literally gone forever, literally irrecoverable. They're truly, truly priceless. They have the impact, the possibility, or at least present the likelihood or the chance at really changing how we think about our species, how we think about our place in the universe. They have a very, very high value that can be measured against or on some level regarded at least as deserving of consideration as commercial or human exploration imperatives. For the scientific community, it's also essential to take the practical step of developing technical standards for what count as missions to the moon that are responsible and that don't present unnecessary risks to SESIs. So technical standards could include, for example, the definitions or specifications of what kinds of frequencies could be used, say on the far side, what levels of vibration might be acceptable or tolerable or not, or would present undue interference to scientific experiments, what forms of dust mitigation or other steps, or what levels of dust disruption, for example, might be acceptable or not to the SESIs around some of these mission destinations. And so the goal would be eventually to perhaps get ourselves to a place where every future lunar mission can be evaluated against a set of technical standards for its compliance with a general set of rules about what kind of missions are scientifically responsible. So we could come to expect that we would do almost like an impact assessment on science of future missions before authorizing them. But a precursor to getting to that stage would be to develop specific definitions of what kinds of missions are allowable and which ones aren't. Beyond that, the scientific community can also work on mitigation techniques. So specific technical solutions to problems like noise or vibration or other technical means that help offset some of the necessary interference effects that we can already anticipate. So there's also a broader external agenda you can imagine for this community that reaches beyond the scientific community to other stakeholders, to decision makers, and maybe even to the general public. I think the long-term ambition should be to try and nest the effort to protect SESIs for SETI in a larger agenda for protecting scientific opportunity on and from the moon. The overarching goal should be to broadly elevate the consideration of scientific interests in global discussions of what space governance should look like and how evolving rules should take shape, so that scientific interests come to enjoy consideration comparable to what today human exploration mission imperatives and commercial interests already enjoy. So to sort of rebalance the kinds of global public interests that receive consideration in global discussions of space governance. Rhetorically, all of this is likely to be more effective if the scientific community doesn't adopt simply a defensive posture, doesn't simply identify sites in need of protection and resist efforts at compromising them, but goes beyond that to articulate what you might think of as a positive vision for space activities, a vision of how humankind can conduct activities on the moon and beyond in furtherance of a range of legitimate interests. So a way for human exploration, commercial activity, and scientific missions to develop alongside each other, hopefully in a way that's complementary rather than in tension with each other. So for my very last slide, I thought I should close out with just a couple of concrete steps you might consider taking in this direction immediately, or say in the next 6 months. It would probably be helpful for the scientific community to try and establish a formal or relatively institutionalized process for SSE identification and protection. And there are already a number of smaller individual international efforts that can feed into such a larger process, including some by the International Academy of Astronautics and beyond that I've listed up here. I also urge you to consider whether or not you want to start to think of yourself as an advocate for scientific opportunity, someone whose job is not just to study space, but also to defend and to safeguard the important forms of scientific equity that exist out there for yourselves and for future generations of researchers. There are many ways to engage governance processes, including by communicating, briefing, your national government, legislatures, your national space agencies, for example, as well as engaging international processes like accepting those invitations to go speak at COPOS, for example, on scientific opportunity, making the point that many of the technical proposals that all of you are developing for exciting opportunities or exciting research on the moon actually hinge for their feasibility on a supportive governance and policy environment, and that efforts in that direction are a necessary complement to all the technical and scientific work that you're already doing. One possible direction we could take some of this work is to explore the possibility of a protocol, so in addition to the Artemis Accords agreement, that would specify best practices or principles or other mechanisms that would protect, scientific opportunity. So a specific protocol on protecting science to attach to the Artemis process. That's one means we could see some of this work growing into. And finally, I urge you all to think about building an interdisciplinary, a formidable and broad interdisciplinary coalition in defense of scientific opportunity. You have many allies, of course, across scientific disciplines, not just people working on SETI or astronomy, but astrobiologists, many other Earth and planetary scientists. But beyond that, you can look even further afield to distant disciplines. There are social scientists and humanists who are very interested in governance questions and the sustainability or environmental sustainability beyond Earth. Ultimately, the solutions that we'll need will be institutional ones, and social scientists are uniquely positioned to contribute on that front. I like to say that bridges are to civil engineers as institutions are to political scientists. So these are problems that we're at least well equipped to help examine with you. Beyond that, there's a community of environmental activists on Earth beyond the professional scientific community that is also increasingly interested in space. There's a planetary protection community. There are many, many other constituencies and intellectual communities out there that could join in this broader effort to safeguard and protect scientific opportunity on the moon and beyond. So with that, thank you very much for your attention, and I look forward to your questions a little bit later.